Light and day is more than you'll say, 'cause all my feelings are more than I can let by or not, more than you've got. Just follow the day, follow the day and reach for the sun. You don't see me flying to the red one more, you're done. Just follow the seasons and find the time. Reach for the bright side. You don't see me flying to the red one more, you're nuts. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun. You don't see me flying to the red one more, you're nuts. Just follow the seasons and find the time. Reach for the bright side. You don't see me flying to the red one more, you're nuts. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun. Just follow the day, follow the day and reach for the sun.
All right, so today is just a course retrospective. We won't even probably take the whole time. You know, what is a retrospective? Oops, sorry. A retrospective is basically, it's structured after, oops, let me make sure that this works. Yep. It's structured after software engineering methodology called Agile, where you split, you know, a project up into scrums, or up into, sorry, what? No. A scrum is your get together where you talk about what the retrospective here. You split it up into sprints, right? So for example, our sprints this year were about 2 weeks, right? Every 2 weeks you had another phase of the project due. In practice, they're usually like 4 weeks. And the idea is that at the beginning of that sprint, you commit to what you're going to be doing for the next 4 weeks, and you say, yes, we're going to be able to get this chunk of work done. You measure that, right? On day one, you've got this much work, and then on day 0, ideally you'd have 0 work. You don't want to see like an immediate drop off that we got everything done on the 3rd day, right? because that means that you're sitting there idle for the next 27 days. You also don't want to see that, well, we're not getting anything done, we're not getting anything done, and then we all cram at the last possible moment and then get everything done at once. We want to see this nice linear curve all the way down. It's called a burn down chart. At the end of that sprint, you have a retrospective, right? You look at your burn down chart and say, well, yeah, we had a pretty good, even split there. What went well, what didn't go so well, and what can be improved for the future. And then you take that idea, you take that retrospective, and then you start planning. Hello, University of North Texas. You start planning for the next sprint, right? And so our retrospective here is with respect to the course. As far as this course went, what went well, what didn't go so well, and what can be improved for the future. Course evaluations are your opportunity to tell me what went well, what didn't go so well, and what can be changed for the future. For this section, we've got 13 enrolled as of the end of the course. We'll talk about that in a moment. And so far, as of this morning, 3 people have filled that out. I do not, it is completely anonymous. I do not know who filled it out. I do not know who has not filled it out. And of course, it's completely up to you. If you don't want to fill it out, then that is a statement that I'm so completely neutral that I didn't even want to bother filling it out. That's about 23% in this section, and it's about the same in the other sections that I'm doing over in Lincoln. I've got 21% and 26%. Really, really encourage you to do that though, so that you can tell me, your perspective on what went well, what didn't go so well, and what can be improved for the future. In particular, for this particular section, this is the first time I've done this up in Omaha, up at UNO. The idea is that this will be the course going forward, so spring 2024. I'm tentatively scheduled to do it again, and hopefully this will be the course going forward instead of, what is it? CIST 1400, or no, not 1400. CSCI 1620. Is basically the old computer science one, which is still being offered by IS&T, but the ECE department wanted to transition over into this version. So it's been offered in Lincoln for many, many years. Now that this is the first time that we're in Omaha, tell us, what could we do differently, especially, is there something unique in Omaha that we're not taking into account? And we'll talk about that perspective here in a second. So before we do that, though, let's understand what we've done, the lessons learned, the skills acquired, and the achievements unlocked, if you want to put it that way. Hopefully, many of you have now had a really good exposure to those soft skills: teamwork, conflict resolution, coordination. If you chose to work alone, that's perfectly fine. Do understand, though, eventually you'll probably have to work in a team at some point. Do you have to work in teams in your other courses, the EE courses? Are they assigned? They're assigned teams. Yes. Yeah. So I don't, at least in an educational situation, I don't believe in that in first year courses, because you're just getting acclimatized, right? That you don't necessarily have the skills, the teamwork skills, the conflict resolution skills, and the coordination skills to get everything done. So that's why I like to expose those to you early. Later on, you're not going to have a choice. The way that I put this in Lincoln is there were several incidences of plagiarism, and I put it to the students in this perspective. Look, there's not much we can do about it if it's endemic, right? People are going to get away with it. There are people that are going to fall through the cracks, and we're not going to catch them. Those are the people that you're going to have to work with as juniors and seniors. Do you look forward to working with somebody who cheated their way through Computer Science 1, Computer Science 2, Computer Science 3, right? So at some point, you will have to do a conflict resolution, because there will be somebody on your team that is not pulling their weight. And it is not, you don't have a choice, right? Because you have been assigned this team, or when you're at work, eventually in your career, you'll be put on a team, and you don't have the power to fire them, right? You have the power to quit, but you don't have the power to do anything about anybody else unless you're the manager. So conflict resolution, how do you deal with somebody that is not pulling their weight, that is not doing their fair share, right? Do you fill in the gaps? Do you try to approach them and try to resolve the situation, et cetera, right? These are the kind of soft skills that hopefully you've been exposed to at this point. Exposed to, not that you have, what do business folks like to call it? Emotional intelligence to deal with it, right? And all those kind of approaches or those kind of tips or whatever. Your toolbox is now expanded, right? You now have a second or even third programming language. Java, SQL is a programming language. And so now you've expanded the number of programming languages that you have, C, Java, SQL. Maybe you want to then get into Python. Maybe then you want to get into C# and do some video game programming with Unity or something like that. C++ or something, yeah? No, you don't want to do that? All right, well, in any case, you are now well equipped to do it when you do have to face it. Why? Because all programming languages are basically the same. You're going to have to do a loop. How does this language do loops? You're going to have to do data processing. How does this language do data processing? Every language is going to do it differently, but they're going to do the same basic operations.
Can't be any more complicated than assembly.
Assembly. Oh, there you go. Now you have a fourth programming language with assembly.
Okay, but that wasn't from this class.
Well, no, but once you've got 1, 2, 3 programming languages, it is much, much easier to pick up a new programming language as you go along. All you have to do is say, I know how to do it in this language. How do I do it in this language? Okay, great. Now I know how to do it there, right?
The problem is that assembly is usually vendor specific or whatever.
Yeah, hardware specific or whatever architecture you're working on. Yeah, unfortunately. But that's what comes from working at a low level with assembly. Much higher level here, you now have exposure to object-oriented programming. From a Java perspective, yes, but there are plenty of object-oriented programming languages like, say, C++, C#, et cetera, and they're all going to have the same basic concepts of inheritance and polymorphism and abstraction and encapsulation. You have some SQL, and you have a little bit more, hopefully, Git background because that is an absolutely essential skill. We've exposed that to you in this first year, where you are simply just cloning stuff and working with it. Hopefully you've been using it as a backup. If you've worked in a pair, hopefully you're using that to push back and forth to each other. Right? You also have experience and perspective building a larger project. Now, I don't know, does your EE project build on itself? And so you're like phase 1, phase 2 depends on phase 1, phase 3 depends on phase 2. Yes, no?
What EE project?
Oh, well, what your circuits project or your assembly project or whatever. It's not, you don't have a project then.
There isn't a project in microprocessing.
Okay, so in microprocessing, each assignment or each lab is individual.
Yes.
Okay, it's all standalone. Well, with this course, you have a experience and perspective building a larger project that builds on each other, on previous phases. With a computer science 1 course, typically, each week you're doing something new, right? And it's not building on each other. Now, implicitly, the knowledge builds on each other. How can you hope to process a file if you don't know how to do a loop, right? So that is, there is transitive knowledge there, but it is not absolutely dependent on each other. And then, of course, now you also have the skills of technical writing with your design documents, maintaining that IEEE formatted document, updating it, iterating it, drafting it, and polishing it until you've got the final submission. Hopefully, because of all this, you have a better understanding of technical debt. Technical debt is basically a loan. The colloquial way of putting this is if you don't find time to do it right the first time, you're going to have to find time to do it over. And so technical debt is, okay, well, let's go ahead and just get it done, right? And I'll throw something at the wall. Okay, well, that's good enough. You're basically taking a loan out on your future time. In fact, it's sometimes some people call it just a blind call, right? Like when you say, I will go ahead and I'm going to sell a contract to purchase 50 shares of Google stock at any price whatsoever 1 month from now, right? Now, you have no idea what your risk is going to be, right? If Google stock goes down in the next month, great, you've made money. If Google stock shoots up, you have no limit to your liability, right? It could shoot up to $1,000 a share or whatever, I don't know what it is right now. But it's not even a loan. A loan is much more predictable. You are borrowing, say, $50,000 to buy an insanely expensive car, and you have a set prescribed way of paying that back over 4, 5, 6, 7 years or whatever, right? So technical debt is actually way more risky than that because you are taking a loan out on your future time. You have no idea how much future time you are borrowing from yourself. Whereas if you had done it right the first time with good upfront design and upfront testing, then you're not accruing technical debt. In industry, when I briefly worked in industry, we call this eating your own dog food, right? So if you design something bad, you're gonna have to live with that. If you make a terrible meal, a dog food meal, you're gonna have to eat it, right? So don't do that, right? Don't you're only hurting yourself when you throw something together, slapshod, whatever the term is, and later on you're gonna have to fix it. Hopefully bad practices have become apparent why they're bad practices, right? Design as an afterthought rather than design first, right? Because if you're not thinking up front about the design, you just immediately start coding, throwing something together, eventually you're gonna have to pay for that down the road. You're gonna be fighting that code to get it to work. For example, the quintessential example from this semester, not necessarily this section, but a whole bunch of people had terrible inheritance or terrible encapsulation on phase 2, where they were computing the total of an invoice out over here outside of the invoice class. Now when it comes to assignment 7, where they have to sort on a list of invoices, they're finding that they can't do it because an invoice doesn't know its own total. Right? You have to go to this other class over here to get the invoice total, breaking encapsulation to even know, well, does this invoice go first or does this invoice go first? And if they had a good design up front, they wouldn't be fighting their own code at this point. The usage of good test cases, good test suites, et cetera, right? How do you even know that it's working, right? Good test cases means that you had at least one of each type of item in your invoice. That good test cases means that you at least had, I don't know, 3 invoices or something like that. Good test cases means that you are testing those corner cases. If you designed a linked list based sorted list, did you test inserting at an empty at the head, at the tail, inserting into an empty list, et cetera, right? This is something hopefully you've pounded out of yourself, that you've broken the bad habit of from the computer science 1, but poor variable names, it's still an issue because not this year, but like a couple of years ago, somebody came in and I helped them debug something, and their loop wasn't breaking out when they thought it should be. And so they were using a variable to control their loop in a while loop. And the variable was some nonsense name, like foo or something like that. And I said, well, what does that variable even stand for? And so they had to explain it to me, right? They rubber duck debugged it and said, oh, it stands for this thing over here. Well, that's not what your loop is saying. Your loop is saying just the opposite of that, and that's why it's not breaking out in time, right? And so poor variable names, hopefully it is obvious why you want to name things that you should, right? You've also seen, YAGNI, you ain't gonna need it, over-engineering. Some people chose, and we really discouraged it, but some people chose to have this really complex database design where they had a table per subclass. So they had an item table, they had 3 subclasses for each one of the types, and then they had 2 more tables for the subtypes of equipments. 1, 2, 3, 4, 5, 6 different tables when all you really needed was 1, right? Over-engineering YAGNI, don't pre-optimize anything. And that goes into, again, bad database design. That you're fighting that database design when you actually go to code and interact with that database. Hopefully you have a better appreciation for the scope of a larger project. working and coordinating in teams if you decided to work, in a pair. And hopefully at the end of the year, you're better coders overall and better designers. The first thing I say in the first Computer Science 1 course that I do is don't compare yourself to anybody else, right? There's nobody else here. But don't compare yourself to other people. Compare yourself to yourself. I had a student one time in their student evaluations put together an evaluation that said, at the end of Computer Science 1 or 2, whatever it was, I looked at myself at the beginning, like I was struggling to do a Hello World program, and by the end of the first year, I'm a coding machine, right? That's your measure of success. Look at yourself maybe, what is it, 9 months ago, not really a full academic year, well, a full academic year, but not a full calendar year. Look at yourself 9 months ago and compare yourself to today, and think about your skills, think about your approaches, and can you honestly say that you're far better? Probably, right? Yes. Well, that's, what is that called? Imposter syndrome, right? Imposter syndrome still affects everyone, right?
No, I am definitely worse than that.
Worse off. I don't believe that for a second.
No, my writing skills become worse.
Okay. All right. Let's talk about those that, or impediments that affected individuals or that were endemic or whatever. The most common issue that we saw was people never really getting started. And I'll show you the actual results of this, of the grade distribution here in a second. Beyond, say, that first easy lab, they never really did the second lab. They never did the first assignment, and they never really got started, right? It's unfortunate, but people, a lot of people in not just this class, but in many STEM courses, they just never get out of the gate at all. Procrastination is still a huge problem, right? And what I've tried to introduce into these courses over the years to try to combat that problem are Gantt charts. Some way to self-organize. Now, I don't know if anybody used the Gantt chart. I'd like to hear if you did. But the Gantt chart was designed to make sure that you are defining what I need to be doing this week, this day, and when it needs to be done. That's only going to take me 3 days. So that it gives you a sense of, am I ahead, am I behind, am I right on time, right? You've got now some exposure to agile development. Again, we organized it for you. We put together all these sprints, these well-defined sprints, because of course it's a course, we have to design it that way. But in the future, if you are ever in, and this is the dominant methodology right now in today's software development world, agile development, where you are a self-organizing team. If you're working with 4 or 5 people in a team, at the beginning of your sprint, you will decide as a team what you're going to commit to that month. You're not going to have a manager coming in, at least ideally, you're not going to have a manager coming in and say, this needs to be done at this point, right? You'll have overall goals, like this project needs to be delivered in 9 months. And then you, as a team, self-organize and say, yeah, we can commit to that 9 months. And here's our overall project idea, here are our sprints, or here's our next sprint at least, right? The idea of agile development is that you are self-organized and that you do not have a manager coming in and say, all right, you know what? I've got a huge fire for you to put out. Drop everything that you're doing and just go over there. With agile development, you have the power because you are a self-organized team to say, no, we're not going to do that. You technically aren't supposed to have managers. You're supposed to have scrum masters and stakeholders. And instead of managers, you have stakeholders that own the product or own or project owners or something, right? And of course, again, design comes first. If you have a well thought out design 1 week before, and that's the whole point of the design documents, 1 week before you even start coding, that's going to be a lot better, right? Have you ever heard of the iron triangle of project management? So you can do it correct, you can do it cheap, you can do it fast. You can pick 2 of those, right? Because if you do it fast and cheap, it ain't gonna be correct, right? If you do it fast and correct, it ain't gonna be cheap, right? And then the other one, right? You have this this iron triangle where you can pick two sides, but you can never pick the third one. You can't have something that is cheap, quick, and correct, right? It just ain't happening. Right?
What if you have three teams that each pick two?
That's a good point. So conventional wisdom would say, all right, well, let's say that it takes us 3 months to complete this project with the three of us or something, right? All right, let's go ahead and bump that up to 9 people. Now it's only going to take 1 month. Nope. Turns out it's going to take 6 months now, right? This is a book called The Mythical Man Month. Right? It's quite old, and it's not really old, but it's a collection of essays based on those conventional wisdoms that never turn out in practice. The idea here is that the more people you throw at a project, right, that's more connections and more complexity in the project. Because if you have 5 people already and you add 1 more, you have 1, 2, 3, 4, 5 more connections. As you increase that, it increases order n squared, right? And the number of connections as you add people. So the idea with agile development, in fact, is to keep teams small, as small as possible, to keep them compartmentalized, so that we work on our stuff, you work on your stuff, and maybe we've got an API between them, right? Loose coupling even in your team dynamics, right? And so, yeah, you want to throw more people at it, go ahead, throw more money at it, and it turns out that it's now 6 months instead. Because of all the coordination.
What's that?
Say what?
Law of diminishing returns?
Exactly. Law of diminishing returns. Exactly. Hopefully, a lot of people suffered from insufficient testing. We saw that exemplified on this last, and again, I'm not talking generally. I'm talking generally among all 3 of my courses of this offering. Insufficient testing on assignment 7. People are going, well, it's really complex. I can't debug this because it's loading up 5 invoices, and I have to, well, why are you testing it with invoices? Why aren't you testing it with integers? Just put 10, 20, and 30 in there, right? Does it work? And if it doesn't work, then you have something much, much easier to debug and much more straightforward to debug. If you can run code, you can run tests. If you can write code, you can run repeatable tests. If you can read code, you can write proper unit tests. Have you ever heard of Bloom's taxonomy? Right, where low order cognitive skills and high order cognitive skills. Low order is down here is like reading, then you get to understanding. And then way up here at the top, you get to creation, right? You understand it so well that you can actually create it. It actually is reversed with code, right? If you can run code, then that's a low level kind of, anybody can run code, right? Anybody can compile it here. This is how you compile, this is how you run. You can, regurgitate the .run or .a.out or whatever, right? If you can write code, you can run repeatable tests, but it takes a much higher order skill, reading code and understanding somebody else's code in order to write proper unit tests to try to break that code, right? You see that code, oh, I see a potential bug there. I'm gonna go ahead and write this test to prove that it doesn't work for that, right? I see that corner case over there. You didn't handle when you inserted into an empty linked list, or you didn't handle it when there are 5 elements in that linked list and then you try to add something to the head or something, right? Those are the corner cases that I would try to probe and try to break your code. Somebody did an excellent job earlier earlier in the semester where they submitted this test case with a whole bunch of garbage Unicode characters and stuff in it, like emojis everywhere and stuff, to try to see if it would break stuff. It didn't break mine, so I don't know if it broke other people's. But ultimately, I don't think we put that in as an official test case. But anyway, if you look at the syllabus for this course, you'll see that these are the skills objectives that have been outlined. You should be able to more easily pick up and learn a new programming language on your own. Why? Because you have now several. Right? You should be able to recognize, use, design, and appreciate programs with an object-oriented programming flavor, right? Rather than just C. Now you have exposure to OOP, and you can think in terms of encapsulation, abstraction, and most importantly, inheritance and polymorphism. How do I write one piece of code so that I never have to deal with that damn problem ever again, right? Sorting, whatever, right? Be able to design and a database-backed application from scratch, given a general problem statement. Right? That's what you did all this semester. You should be able to understand and implement basic data structures, as well as recognize how and when to leverage appropriate simple data structures, and then of course same with algorithms. Right? Again, the theme of this course is from Eric S. Raymond, Cathedral and the Bazaar, that smart data structures and dumb code are a lot better than the other way around. And the idea here is that by the end of this course, so at the end of this Computer Science 1 course, you should be able to take a problem, design a top-down solution. In other words, break that problem up into smaller and smaller chunks until you get to, okay, well, this is a function, this is a built-in function, or this is one line of code, or, okay, that's a function that I have to write over there, right? Once you got down to those little tiny pieces, then you can start building it up back up. By the end of this course, however, you should be inverting that thinking. You should be able to approach a reasonably complex problem and ask design questions first. What classes should I create? What entities or objects would be appropriate to model this problem? How will these objects interact to solve the problem, right? For example, a store. I want a store report that has a bunch of invoices. Clearly, a store is going to need to own a list of invoices. And what's an invoice? An invoice is these things over here, right? Well, an invoice is a salesperson. Is a salesperson just a code? No, a salesperson is a person. There's another object, right? Because I'm going to want their first name and last name to print it out in a report or something. Right? Say what?
Also, the invoice has the store.
Exactly. The composition and how these objects interact with each other.
Something, don't cut. The stack overflow from the curtain, something.
Yep. If you've got by composition or whatever, then yeah, you do have to be careful of that, of the ping-ponging back and forth. Also, what data structures would be the most appropriate and efficient to use? That I recognize that problem. I can go ahead and pull this heap off the shelf and just put stuff in, take stuff out, and I've got heap sort, right? I recognize that problem. That's a stack problem. I can just put stuff in and pop stuff out, and that ordering is exactly what I want, right? Whatever problem you see and you say, okay, I can model that as this graph problem over here, and I can bring this graph algorithm in and get the job done. Right? We'll talk about graphs here in a second. The big takeaway that I want you to have from this course, if nothing else, regardless of how well you did or how well you hope that you'd done, is that you may have done some or a lot of things poorly or wrong, but that's part of the learning process, that the next time you will do better, right? You won't make those same mistakes again, that you won't make the same design mistakes going forward, or process-oriented mistakes, or procrastination, or whatever. Right? The other key takeaways, hopefully, that you've had implicitly throughout this is that what is a computer scientist, a software engineer, a computer engineer? You're all these things, right? You're lawyers, you're philosophers, you're diplomats, you're managers, designers, creators, writers, thinkers, and programmers. Right? And I don't know. I mean, you could make that case for any discipline, but I think that computing discipline is uniquely all of these things. Why? Because everything is computing, right? You're not going to have, soon we're going to live in a world where you cannot be in discipline X, Y, Z without some sort of computing skills. And so if you're at the center of it all, if you're at the center of computing, then you're all these things automatically. I tell you, lawyers, yeah. Just this last week, I had a cease and desist letter sent to me by have you ever heard of copyleft trolls? Right? So when you take up, say, a photographer takes a picture and they release it under a Creative Commons license. I've released all my books and my videos under a Creative Commons license, meaning that anybody can use them for any purpose as long as and I put an attribution license on it, as long as they give me credit for it. My name appears somewhere. They can't take my book, cross out my name, and then put their name on it, right? That's what my license says. There are the Creative Commons license are the opposite of copyright. They're copyleft. That you want people to use this and freely use it. People release, royalty-free music all the time. But then you have what are called copyleft trolls, where are these companies that people sign up for, and they automatically try to detect anything that violates the letter of the law. Oh, you didn't say their full name, or you use their picture, but you didn't put a name clearly under it. You just put it in the metadata, or you did this and you should have done this. And so they'll try to shake you down and send you a letter and say, well, you can go ahead and resolve this now for $750, right? Don't pay it, right? You have to be, first of all, the thing that they sent it for was a picture that was released under a Creative Commons license that was used by a student in a course for a student project. This falls under the doctrine of what's called fair use, right? And because I'm a lawyer, I'm not a lawyer, but because I know just a little bit enough of the law, I knew that, well, no, it's bull. They have no grounds. And so when I sent it on to our general counsel and said, there's no grounds for this, you'll need to respond. Somebody else got involved that should not have and immediately sent a response back. That's a big no-no. You never talk to cops, you never talk to lawyers, period, right? It will never, ever help you. Instead, you send it on to lawyers. The lawyers know what they're doing. The lawyers know how to resolve the issue and speak in lawyerese so that you're not opening yourself up to admissions of guilt or liability. You have to be a lawyer in some sense because you have to know just enough to not get yourself into trouble. If you do, say, steal somebody's code and use it in an actual product, guess what? Now you have huge liabilities. So you have to be a little bit of a lawyer. You have to be a little bit of a philosopher, right? You can argue back and forth that I think that this design A should be should be what we do. You have a partner that says, no, I think design B is better, right? They both work. They both have advantages and disadvantages. And now you have to be a philosopher. Do these advantages outweigh the disadvantages? Do those disadvantages outweigh the advantages, right? And you have to go back and forth as philosophers to say, I think we should use this pattern over here because X, Y, Z, right?
Does that really count as philosophy?
Yeah. What is it?
Diogenes?
Not Diogenes, no. Not Dianetics either. Dialectics, there we go. An argumentation and going back and forth, right? You also have to be diplomats because, again, conflict resolution. Not necessarily that I saw it in this class, but in plenty of other classes, we had issues where, I need to find a new partner. They're not doing anything, right? So cutting those ties, but being diplomatic about it, right? Never burn a bridge, right? If you're going from company A to company B, try to do it as professionally as possible because who knows? You may eventually go back to company A. You want to leave that door open unless you're absolutely sure, no, that's never going to be an island that I ever want to visit again, then go ahead and burn your bridge. But yeah, I mean, be as diplomatic as you can with anybody because you never know what the future holds, right? If you build relationships in company A and you leave because person X, Y, Z or whatever, you still have those relationships and those people are going to be at other companies. And you might have those networking connections where you can get in good with another company because you preserve that relationship. You have to be a little bit of a manager because you have to manage yourself at the very least. You have to be designers, creators, writers, technical writers, thinkers, and programmers, of course. Why did I put programmers way at the bottom here? Because at the end of the day, when you think about your career as a whole, say 40 years, if you're lucky, the amount of programming that you actually do is going to be really, really small. In fact, as you go through your career, the amount of programming you do is going to be is going to diminish, right? There was an excellent meme somebody published. There was an excellent meme that somebody published on Reddit, on the programming subreddit, where there's this nice gentle curve. A beginner programmer will be programming, say, 10 lines of code an hour, right? And then as you get up, you're getting 100 lines of code an hour, 200 lines of code an hour. But the expert programmer, -5 lines of code an hour. Why? Because they look at crap code and say, cut that, 50 times more efficient, right? So, in fact, what is the, I forget who it was. How do you know when something is done? Not when there's nothing left to add, but there's nothing left to take away, right? And so you've got the bare minimum of what it needs to be. It's as simple as it gets. Any more further cuts and it breaks. So again, programming is actually going to be a small part of what you do overall, right? Here are the final stats for this section. I've not run the stats for the other sections yet, but unfortunately, we started out with 25. Right now, as of, you still have the assignment 8 and the design document, so don't think that these are the final. But the distribution is pretty much there. 7 A's, 3 B's, and unfortunately, a 60, what we usually call a DFW rate, those receiving D's and F's or W's. In other words, those that are not receiving a sufficient grade to move on. And I'm not sure what that is here at UNO, excuse me. But unfortunately, it's about 60%. To understand that, look at the week by week, right? So week 0, everybody was getting those free starter points. Everybody was getting an A, right? Week 1, everybody did the first lab because it's a freebie, kind of just hello world kind of lab. But when did people, so here's week 14, where we've got that distribution that I just mentioned, where we've got, what was it? 12 W's, 12 withdrawals, and then here we've got only 40% passing with A's and B's, right? Where did that stabilize? Well, it stabilized exactly in week 7, but really, if you look, it stabilized in week 3. What happened in week 3? That was the first assignment, right? So again, when I said that by far the biggest issue was people not getting out of the gate, there it is, right? People not getting out of the gate. I've engaged ESS. Do you call it ESS? The Advising Center. What is it called? What does ESS stand for? Anyway, the advisors. I've engaged advisors, and their thinking was, I've got the schedule right here. Their thinking was that the term 2 is really, really overloaded with microprocessor, the seminar, Calc 2, Physics 1, and then some introduction to electrical and computer engineering. But this course is just a replacement of CSCI 1620. So unfortunately, to compare this, and compare this, I really have no historical numbers, all right, because I don't have any access to data at UNO. Not 1400, sorry, it's 13 or 1620. So I'm not sure what the DFW rates, the ABC rates are out of the old version of this course, but I can tell you that the number of courses and the number of credit hours has not changed. So ESS, I'm not buying it, what they're selling. Maybe, I mean, compared to Lincoln, I do think that I get the sense at least that the microprocessing applications is a little bit more than what's in Lincoln. We don't have microprocessing applications, instead they do discrete math. But I can tell you that the number of people who fail discrete math is probably exactly the number of people who fail microprocessor applications. Right? Well, how is microprocessor application going?
Those aren't really equivalent courses.
No, they're not equivalent, but the failure rates likely are. How is it going?
Pretty terribly. From what I've seen, most people in the class are getting grades on exams between 40 and 65.
Okay, so it's exam heavy, grading based.
He is very exam.
Okay.
Well, I mean, there's only been like 2
There have been 2 exams. We got a final on Monday.
I still don't know how to.
It sounds very traditional, in that it's a traditional formative assessment. Like a lot of STEM STEM, including math. The Calc used to be like that. I don't know if it still is. But I don't adhere to that philosophy. I think that everything should, I have 0 exams here, right? Everything should be formative assessment. They're a summative assessment. I always get those mixed up. Where, you have a grader. You can resubmit it 50 times if you want, right, to get it up to perfect. But the historical perspective that I do have here is that, at least in Lincoln, among computing majors, it's really only a 20 to 30% DFW rate. So what happened here? I'm chalking it up to smaller numbers are subject to bigger perturbations, right? Because we're only 25 folks here. I've got 175 in Lincoln. So yeah, I mean, it looks like it's twice as bad, but also it's like 1/7 of the enrollment. So the small issues, you know, end up being bigger, end up being a lot bigger. It doesn't explain twice as much in my book, but it does go a little bit in that direction. Maybe it's, so that's why I'm relying on you and your course evaluations to tell me. Unfortunately, we're not going to get the perspective of these folks right here, right? Because they're not, they don't have the course evaluation. But on their behalf, if you can tell me what happened, why didn't they get out of the gate, right?
I don't know, I don't talk to people.
Okay. I generally try not to talk to people too, but it's my job. I don't like it, but no, I like it. So what you have left is your assignment 8, your design document. Make sure that you review our feedback that we gave you on your design documents throughout the process. If you didn't have that kind of feedback, make sure that you're reading our feedback that we posted generally on Piazza. Again, no final exams because there are no exams. Final stats to be posted, of course. And by the way, historically, I did used to have like an exam, a midterm and a final for this course. It was like a bubble sheet kind of thing. And yeah, it started out like, say, 20% of your grade total. And then, all right, well, we cut it down to 10%, cut it down to 5%, right? And then eliminated it entirely. Guess what? There's zero difference in the outcomes, right? So that's why I was fine. Why I finally eliminated it, because it was not necessary, right? That anybody who did the assignments and did well on the assignments did well on the exams. Anybody who did not do well, and so it was not a necessary measurement anymore, and I got rid of it. Where are you going to go from here? I just looked it up really quick. Term 3. Lots more circuits. Term 3 and term 4, you've got electrical circuits and then electronic circuits and switching circuits theory. I don't know enough EE to know what the hell the difference between an electrical circuit is and an electronic circuit is.
I don't know. All I know is that I can't take physics this next semester because of the electrical circuits.
Okay.
Same. I was just invited yesterday.
Do you look for summer equivalencies if you can?
I can't.
No?
I'm already taking 3 summer classes,
Okay.
assuming I pass Calc 2.
All right. My condolences. Anyway, normally what you would do next is a CS3 course, which is data structures and algorithms. But according to this, you don't do that until your junior year. And that number is here, it's CSCI 3320. Talk to your advisor though, because I'm not an advisor. This is just what I'm going off this sheet. Right? Anyway, professional, what are you doing from here? Internships, right? You are now more than qualified for most of the internships that are out there. I would encourage you, if you're not going to have an internship this summer, go to the fall career fair, go to the spring career fair, and get an internship in your second one. Internships are basically your opportunity to try jobs out, right? Go to company XYZ. No, I hate company XYZ. Right? Then that saves you from having to get a job there, right? Or I love company XYZ. I want to take my internship and roll it into the next 5 years after I graduate, right? And that's your opportunity to test these things out and get paid, right? Keep frosty. Over the summer, you could learn a new language, build a project, do whatever, right? Over the summer, what am I doing? Oh, it's education related. I'm preparing a bunch of modules for parallel and distributed computing and introducing them into Computer Science 1. So that's what I'm going to be doing. What are you going to be doing?
English composition.
English, okay.
Linear algebra, I think.
Linear algebra? There you go. So you will be given a bunch of busy work in linear algebra to solve a bunch of systems of linear equations. Guess what you could do? You could code that up, right? And have it print out a bunch of LaTeX code so that when you turn in your assignment, say, here's my Gauss-Jordan elimination, right? And it prints out a bunch of matrices for you, so you didn't have to write them all by hand, right?
What?
You'll get there.
Wait, I thought matrices were for Calc 3.
Yes.
Well,
but
yes.
you do a lot of that
in Calc 3, but linear algebra is all about systems of linear equations.
It's like matrices and stuff, yeah.
Bases and finding eigenvectors and values and all that crap.
Regardless, also calculus 3 if I pass calc 2.
Okay. Unfortunately, with Calc 2, everything's symbolic. Calc 2 and 3, they want you to do everything symbolically, right? But you could always program a Simpsons rule integration program or something, right?
I'm not allowed to bring a calculator,
All right. Again,
and I don't know how
homework.
to use a
Right.
calculator to begin with.
I don't have the equivalent here for Omaha, but if you were, we have something called Bits and Bytes over in Lincoln. It's just a weekly newsletter. We also have a student advisory board, and they maintain this Discord. You're welcome to join if you want to, but it probably won't have too much information that's germane to you. So what I would encourage you to do instead is get involved with your own IEEE society, IEEE, right? And that's basically your opportunity to create a student advisory board. Maybe you have a Discord already, I'm not sure. Do you? Oh, you do? Okay. Then great. Go ahead and join that Discord, whatever it is. Share it amongst yourselves on Piazza if nobody knows what it is. Otherwise, I want to thank all the students who helped on Piazza. I wanted to thank the two TAs that we had for various times throughout the semester. We don't have course leaders, learning assistants here, but same basic thing. I wanted to thank everybody online and here who took the class and wish everybody a great summer. We will not be having a lecture or a lab session on Thursday, so you can show up and work here if you want to, or you can work down there if you want to, but otherwise, any questions, I will be there today, of course, but any questions, go ahead and post to Piazza. All right, have a good summer. Uh-oh, wants me to update.